So, hello, good morning. I'm Khrystina. I'm engineer and project manager in eCognition team. I'm based in Stuttgart. Today, I want to talk a little bit about eCognition in the cloud, about the setup, our experience with the setup of eCognition in the cloud environment, about the use cases of our customers, our own use cases. And I will start with a little history. So it's not news that cloud processing has become an increasingly popular because of many benefits. For us, it is, of course, also important to improve in this direction and to make eCognition cloud ready. So back in 2020, when we released eCognition 10.0, we also provided two Docker images, one for eCognition server and one for eCognition license manager. eCognition command line engine. But eCognition license manager, a user had to set up this licensing himself. We had a very extensive step-by-step guide on how to do this in our community, in our documentation. But it was still a little bit challenging for an experienced user to set up licensing. So that's why in 2021, we released eCognition 10.1, and in that version, we packed our eCognition license manager as a Docker container. And this significantly simplified the procedure and move into the cloud environment through enabling one-line deployment. In this slide, I have mentioned Amazon Web Services, Google, Microsoft Azure, but it is important and worth mentioning that we are not dependent on any cloud platform. So a user can use open source or either these three platforms to set up his cloud environment. So it doesn't matter which one. Then I will talk a little bit about the why move eCognition to cloud. It's probably very obvious. First of all, it's very cost effective because you don't need anymore to invest into very expensive hardware that gets very quickly outdated. It's scalable, so you can tailor the say storage, memory, processing to your project needs. So sometimes you have a bigger project, sometimes you have a smaller project, so you can control the resources that you need. The enhanced security, which is very relevant for especially maybe governmental organizations. For example, data encryption, it is native to cloud environment, so you don't need to use the third-party applications. The automated disaster recovery, it's also a big benefit. And then you don't need to care about the physical storage of your data. But these reasons are probably very obvious. Everybody knows them. What is very interesting, especially for eCognition users, is that it is very flexible. So the flexibility, what I mean by that eCognition can become your microservice. You can build your own solutions on the top of eCognition Docker images, and you can adapt eCognition to your own workflows. So basically, you just plug eCognition into your cloud scenario, and eCognition becomes a microservice. So it's basically a building block. It can become one of the building blocks of your big cloud solution. Yeah, so eCognition is basically now completely cloud ready. And on the webpage of Docker Hub, we have 8 Docker images that are available for 8 repositories that are available for download. There are 3 for Windows and 4 for Linux. So we have the Docker image with the suffix you can see on the slide CLE. It's the command line engine. It is available for Windows and for Linux. Then there is a Docker image with the suffix ES. It's engine server, also available for Linux and for Windows. For Linux, additionally, we have this engine server Docker image with the CUDA capabilities. And there is job scheduler available for Windows. And additionally, there is an image for license server. The image for license server is available only for Linux, but it is not a problem because it is not problematic at all to let's say, set up your licensing on the Linux and then use the container, for example, command line engine container on Windows. So it's not a problem. And in our documentation and on our Docker Hub page, we have a very extensive guideline on how to set up your cloud environment with eCognition. And it is true that it will take some time and knowledge, of course, to set it up. But the good news is that you have to do it only once. We internally, of course, have experience with setting up such environment with cloud processing with eCognition, and we have a special experience with AWS, with Amazon services. So if, for example, you would like to set up to run eCognition on AWS on Amazon, first you would add a new cluster in ECS, and into this cluster is basically a group of services and tasks. In this cluster, you can start adding containers. First, you would probably add the container with your license manager, so to set up the licensing. And then you have two choices. You can choose either add an image as a container with the command line engine, or you can opt for a combination of job scheduler and eCognition server. So those are two options. And what majority of our customers do, and what we do and what we recommend, because it's simpler, is to opt for command line engine. Why is that? First of all, it's simple, it's more cloud friendly, and you have better control over processing, over your input and output than when you're using eCognition server image in the combination with the job scheduler image. But there is one but. If you are using the command line engine container, you have to take care of, you need to wrap it with a data management code. And this data management code can be written either in Python, in .NET, so basically your choice. And this code would automate the procedures, it would automate the download of the input data, the upload of processing results. And also, if you want to parallelize your processing, so for example, you have not only one license, not only one eCognition engine, but you have, I don't know, like 3, 4, 5, 10, and you would like to run processes in parallel, so you would like to distribute the tasks between the engines, this code, this piece of code can or has to do this as well, in case you're using a command line engine. The other option that I was talking about is the eCognition server together with job scheduler. It's mostly it's a legacy thing. That means it resembles the old eCognition grid. In this case, it is less cloud friendly, and it's a little bit more complicated and has a little bit more constraints. You have to ensure the network correct connection between the job scheduler and eCognition server, which is the task on the top of other tasks. And you have to manage your network share. So generally, it's not a very cloud-friendly solution. The only advantage of using eCognition server with job scheduler instead of command line engine is that you would have access to the workspace. If you're using command line engine, you cannot work with the workspaces. But considering that most of the times you don't need the workspace, you can use the command line engine. And it's simpler, it's more cloud friendly, it's what the majority of our customers basically use. As I mentioned, okay, let me start the video. As I mentioned, we also, in our team, we have experience with setting up the cloud purchasing with eCognition. So we worked with one of the teams in Trimble. Basically, what they wanted to do, they had the classified point clouds, and the point clouds were tiled, They wanted to detect the individual tree crowns in those tiles of point clouds and use it for assessing the risk for transmission distribution networks. So simply speaking, there should be no trees in certain area around the power lines or below power lines. So what we did, we received the tiles of the classified point clouds as in LATS format, and we needed to provide them output vectors delineating the crown of the trees. In our scenario, we used Amazon, so user uploaded the tiled point cloud into the Amazon, into the S3 bucket. Then once a tile was uploaded to cloud, Lambda submitted a message into the message queue. And then maybe I'll start with one more time the video. So user uploads the tiles into the Amazon cloud. Then Lambda submits the message to the message queue, and from this message queue sends a message to the engines, eCognition engines, and that's when the processing of the tiles starts. So basically, we had a rule set that extracts this individual tree crowns, and we had few engines working in parallel. So let's say if you have 5 licenses, you can set up 5 containers and process 5 tiles of your point cloud in parallel. Then when tile was ready, the outputs with the tips and with the vectors were passed back to the cloud. And when all the tiles were processed, Lambda submitted the message to the message queue again that the processing is ready. All tiles are processed, and it sent the message again to the eCognition engine. But this time, eCognition engine starts stitching the tiles, stitching the vectors together. So we have the whole picture with the tree crowns. So this was our setup, and this is very similar what our users would do as well, or they are doing this actually already. This is a schema with architecture. So basically, in this scenario, user just has to upload the tiles to the S3, to the predefined folder on S3 on Amazon, and the rest was automatic. The job was triggered automatically once all the tiles were available in this S3 folder. And yeah, here in our case, the processing was scaled to multiple engines, and the tasks were distributed with the Python code. Maybe it's worth mentioning that here we used Linux for the license server, because previously I mentioned that license server is available only for Linux. But the processing was done using Windows command line engine Docker image, because point cloud handling is available only for Windows in eCognition. Then Lambda function here triggered the unzipping service, which is basically a Python script that unzips the tiles and submits the tiles for processing. And the other more interesting use case, the flexible integration of eCognition. So when I was talking about the benefits of cloud processing, I mentioned that the most interesting part is that it's flexibility. So eCognition can become a microservice for your solution. You can integrate it into your cloud scenario. And that's what we did as well internally. We did internal integration within Trimble, where eCognition wrapped in a Docker image is used as a microservice for a web-based software called LibCount. This is basically the software for MEP contractors. MEP stands for mechanical, electricity, plumbing, and it also links with the enterprise estimating software that provide a tool for estimating costs for such MEP projects, so mechanical, electricity, plumbing. Basically, what we did here, the software is basically web-based, and we used our eCognition Docker image, and we developed a rule set that can detect certain elements, user-defined elements in the drawing. So, for example, you have a drawing with the infrastructure of your building. You have, for example, I don't know, there are fire alarms or telephone outlets, those kind of things. And for example, as a user, I want to take my drawing and detect all telephone outlets in this drawing. I would just define a small region to show the software how the elements I want to search, every instance I want to find in the drawing looks like. I define this element, I press the button, and then what the software does, it finds all such elements in this drawing, and it also can visualize these elements in the drawing. And to implement this feature, we created a rule set, we wrote a rule set, and in eCognition, and created a microservice of it, and integrated this into this software called LiveCount. So basically, eCognition is a building block, microservice of this whole software. It's just a part of their complete solution. And this is it from my side. I hope it was something new, interesting for you. Thank you. If you have any questions,